Okay, so the job for today is, or for right now, is we are going to be talking about Maclaurin series and just a little review of that and a way to show how to use this incredibly beautiful formula. And I thought about just showing the solutions to this worksheet right here, just to make sure that you know how to do it and how it goes. And these take a while to load up, so I might just do one question at a time. I might do and see how that goes and then just label them really well. But I think that's what I'll try. So let me just go with the first one here and see how that goes. I might do a little zoom in here. Whoop. And ooh, that looks good. Okay, maybe a little closer. My technology isn't the greatest, but actually that's pretty good. Okay, so here's our formula there, which we know, and it says create the 7th order Taylor polynomial, which of course just means it needs to go up to the 7th degree. Ooh, there's a big old shadow right there. Okay, hold on. There we go. Okay, so we're just going to go up to the 7th degree, and it's centered at 0 for cosine of 3x. Now, the interesting thing about this is we already know. I'm going to prepare myself with my folding technique, splitting that perfectly down the middle. Whoop. Fold and pinch. I'm just going to sort of use this as an idea to say, hey, let's modify the known series, which we have memorized. Hope you all are doing great today. It's a really great day to learn a lot of calculus and to get better at what we already know. Now this is really cool because this is the cosine series we know. So if we just want to make a cosine 3x, we're really just going to be putting 3x in for every x. Now it says 7th order, which means it's kind of a silly question. I should have said 6th order because 7th order is going to stop right in the middle here. But oh well, what's done is done. So all I'm going to do is replace the x with the 3x in my known series, memorize these. So 1 minus the 3x squared over. Now remember, cosine thing is just 1 minus chunk squared over 2 bang plus chunk to the 4th over 4 bang minus chunk to the 6th over 6 bang. If you're watching this, I'm saying bang for factorial. 3x to the 4th over 4 bang minus 3x quantity to the 6th over 6 bang. And that's where I'll stop, right? That's where I'll stop. I guess we could also do our nth term formula, x to the 2n over 2n bang. But this, I'm going to start with 2. 2 gives me a 4 for n, which is positive, so I'm going to go like this. So I'm not going to think too hard about this. I'm just going to replace my x with my 3x and say that's good. Not just say that's good, realize that's good. And I think we're okay there. I'm thinking now with my next ones I might go on a bigger sheet so I'm not crammed in this little space, but that's okay. I think we're fine. So then that becomes 1 minus, now we could sort of leave it like this, but we want to be careful because this isn't actually a series in proper form yet. We don't have our coefficients in front. So I would go ahead and call this 9x squared over 2 factorial plus, now 3 to the 4th is 81 x to the 4th over 4 bang, but then I don't really feel like multiplying, so I'm just going to call this 3 to the 6th, x to the 6th over 6 bang. And there it is. So there's our answer. But over here, it says let's use it with the Maclaurin series formula. This is cool because cosine of 3x, and this is going to take a little bit of work, and I'm going to do this off to the side here. So cosine, I'm going to move this over just for a minute. Okay. So cosine of 3x, when I stick in the 0, is 1, because cosine of 0 is 1. So there's my f of 0, which is 1, plus, now my derivative. My derivative of this is negative 3 sine of 3x. Little chain rule review. Cosine is derivative of cosine is negative sine times the derivative of the inside. But that at 0, of course, is 0, so I need another one. My next one's going to be negative 9 cosine of 3x, which finally gives me something when I stick in a 0. Cosine of 0 is 1. Negative 9 times 1 is negative 9. Here we go. Negative 9. So this one was 0, so I'm going to the next one. Negative 9 x squared over 2 bang. Hey, look, these match, which is good, which they need to. This is a good way to actually do these problems to make sure you know how to do it both ways. My next derivative is positive 27 sine of 3x at 0, which is 0. And then my next one is 81 cosine of 3x at 0, which is 81. 81 times 1 is 81. So I had my next one was 0 right here. Wait, where do we go? 1, nothing. Negative 9, nothing. Then we had our 81 x to the 4th over 4 bang. Plus, now we got to do this again. So I'm going to call this 3 to the 4th. So now I've got negative 3 to the 5th. Gives another 3 in here with the chain. Oh, this is kind of cool. And that's 0. Then we have negative 3 to the 6th. Cosine of 3x at 0, which is negative 3 to the 6th. And finally, what is that? 243. 729. 729. Well, regardless, there it is, which is kind of cool that I can do it with modification. I think the modification's simpler because this right here, you had to do a lot of work. You had to take a bunch of derivatives and do that. So I'm just going to say that for ease of time, and I would imagine in an FRQ where they're asking you to do something, both ways are okay. But this guy, you can see the merit of memorizing the cosine series because all we have to do is modify it. And there is practice problem number 1.